Inheritance. Introduction. We will discuss the following topics in this chapter: classes, superclasses and subclasses, object, the cosmic superclass, generic array list, object wrappers and auto boxing, reflection, enumeration classes, design hints for inheritance. Classes, superclasses and subclasses. The SA relationship is the hallmark of inheritance. Use the Java keyword extends to denote inheritance. The keyword extends indicates that you are making a new class that derives from an existing class. The existing class is also called the superclass, base class or parent class. The new class is also called the subclass, derived class or child class. Subclasses have more functionality than their superclasses. When designing classes, you place the most general methods into the superclass and more specialized method in its subclasses. A subclass can add fields and it can add methods or override the methods of the superclass. However, inheritance can never take away any fields or methods. Java uses the keyword super to call a superclass method. Inheritance hierarchies. The collection of all classes extending a common superclass is called an inheritance hierarchy. The path from a particular class to its ancestors in the inheritance hierarchy is its inheritance chain. Multiple inheritance is not supported by Java. Polymorphism. The IJPL rule states that every object of the subclass is an object of the superclass. Another way of formulating the IJPL rule is the substitution principle. The principle states that you can use a subclass object whenever the program expects a superclass object. Object variables are polymorphic. For example, you can assign a subclass object to a superclass variable. Employee E equal to new employee, employee object expected. E equal to new manager. Okay, manager can be used as well. Dynamic binding. It is important to understand what happens when a method call is applied to an object. Here are the details. The compiler looks at the declared type of the object and the method name. Next, the compiler determines the types of the parameters that are supplied in the method call. This process is called overloading resolution. If the method is private, static, final or a constructor, then the compiler knows exactly which method to call. This is called static binding. Otherwise, the method to be called depends on the actual type of the implicit parameter, and dynamic binding must be used at runtime. When the program runs and uses dynamic binding to call a method, then the virtual machine must call the version of the method that is appropriate for the actual type of the object to which it refers. Preventing inheritance. Final classes and methods. Classes that cannot be extended are called final classes. The final modifier in the definition of the class indicates this. Example: final class executive extends manager, open bracket, close bracket. There is only one good reason to make a method or class final is to make sure that its semantics cannot be changed in a subclass. Casting. The process of forcing a conversion from one type to another is called casting. You can cast an object reference from one class to another. Example: manager boss equal to new staffer. To use an object in its full capacity after its actual type has been temporarily forgotten is the only one reason why you would want to make a cast. To sum up, you can cast only within an inheritance hierarchy. Use instance of to check before casting from a superclass to a subclass. Abstract classes. Use the abstract keyword to eliminate the need to implement the method. A class with one or more abstract methods must itself to be declared abstract. Abstract class person open bracket public abstract string get description of close bracket. In addition to abstract methods, abstract classes can have fields and concrete methods. Abstract methods act as placeholders for methods that are implemented in the subclasses. When you extend an abstract class, you have two choices. You can leave some or all of the abstract methods undefined. Then you must tag the subclass as abstract as well. You can define all methods and the subclass is no longer abstract. A class can even be declared as abstract even though it has no abstract methods. Abstract classes cannot be instantiated. No objects of that class can be created. Protected access. You declare a class feature as protected when you want to restrict a method to subclasses only. Here is a summary of the 4 access modifiers in Java that control visibility. Visibility to the class only, private. Visibility to the world, that is public. Visibility to the package and all subclasses, that is protected. Visible to the package, the unfortunate, that is default. No modifiers are needed. Object, the cosmic superclass. Every class in Java extends object. Some services provided by the object class are the equals method. The equals method in the object class tests whether one object is considered equal to another. The equals method, as implemented in the object class, determines whether two object references are identical. Object A dot equals of object B. The Java language specification requires that the equals method has the following properties. It is reflexive. For any non-null reference x, x dot equals of x should return true. It is symmetric. For any references x and y, x dot equals of y should return true if and only if y dot equals of x returns true. It is transitive. For any references x, y and z, if x dot equals of y returns true and y dot equals of z returns true, then x dot equals of z should return true. It is consistent. If the objects to which x and y refer have not changed, then repeated calls to x dot equals of y return the same value. For any non-null reference x, x dot equals of null should return false. The hash code method. A hash code is an integer that is derived from an object. The hash code method is defined in the object class. Therefore, every object has a default hash code. That hash code is derived from the object's memory address. Example, the string class uses the following program to compute the hash code. Import java.io.asterisk public class hash open bracket public static void main string arguments open bracket string str equal to new string of the incredible India system.out.println of hash code for str plus str.hashcode of bracket closed. Output hash code for str minus 1031839733. The toString method. It returns a string representing the value of this object. The toString method of the point class returns a string like this. Public class test open bracket public static void main string argument open bracket integer x equal to 5 system.out.println of x.toString system.out.println of integer.toString of 12 bracket closed. The toString method, this returns a string object representing the value of this integer. The above program returns a string object which represents a specified integer. Generic array list. The array list class is similar to an array but without any additional code to it. It automatically adjusts its capacity as you add and remove elements. Array list is a generic class with a type parameter. In the below given program, contents are added to the array list by using add function. Then remove method is used to remove the contents from the array list. For example, accessing array list elements. Use the get and set methods to access or change the element of an array. For example, to add the ith element, use a1.set of I, e. You can remove an element from the middle of an array list a1.remove of 0. Compatibility between typed and raw array list. For added safety, always use type parameters. Suppose you have the following legacy class. In this program, you can pass a type array list to the update method without any cast. Call method and pass array list as an argument. Odd cats of list. The list object is simply passed to the addCats method. Object wrappers and autoboxing. All primitive types have class counterparts. For example, a class integer corresponds to the primitive type integer. These kinds of classes are usually called wrappers. The wrapper classes have obvious names as integer, long, float, double, short, byte, character, void, and boolean. The wrapper classes are immutable. You cannot change a wrapped value after the wrapper has been constructed. They are also final, so you cannot subclass them. It is not possible to form an array list integer. It is okay to declare an array list of integer objects. Array list integer list equal to new array list of. Java makes it easy to add and get array elements. The call list.addOf3 is automatically translated to list.addOf integer.value of3. This conversion is called autoboxing. It is automatically unboxed when an integer object is assigned to an integer value. That is, the compiler translates integer n equal to list.getOfI into integer n equal to list.getOfI dot integer value. Automatic boxing and unboxing even works with arithmetic expressions. Use the following statement to convert a string to an integer. Integer x equal to integer dot parseInt of s. Important methods of the integer class. Integer int value. Static string toString of integer I. Static integer parseInt of string s. Static integer parseInt of string s comma integer radix. Static integer value of string s. Static integer value of string s comma integer radix. Enumeration classes. Example: public enum day open bracket Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. The type defined by this declaration is a class. This class has exactly 4 instances. It is not possible to construct new objects. Uses double equal to compare values of enumerated types. Add constructors, methods and fields to an enumerated type. Example: all enumerated types are subclasses of the class enum. They inherit a number of methods from that class. In the above given program, the enumerated day is declared and assigned the values from Sunday to Saturday. The object has been created for the day enumerator, and the print day greeting method is called by passing the enumerated variable. In the print day greeting method, the day is checked as Friday. If it is not Friday, then the output is printed as some other day. Reflection. The reflection library gives you a very rich and elaborate toolset to write programs that manipulate Java code dynamically. In Java Beans, this feature is heavily used. A program that can analyze the capabilities of classes is called reflective. The class. While a program is running, the Java runtime system always upholds what is called runtime type identification on all objects. You can also access this information by working with a special Java class. The class that holds this information is called somewhat confusingly class. The getClass method in the object class returns an instance of class type. A class object defines the properties of a particular class. The most commonly used method of class is getName. It returns the name of the class. System.out.println of e.getClass of .getName of plus e.getName of. You can obtain a class object corresponding to a class name by using the static forName method. String class name equal to java.util.date class cl equal to class.forName of class name. A that method for obtaining an object of type class is if t is any Java type, then t.class is the matching class object. For example, class cl1 equal to date.class if you import java.util.star semicolon. Class cl2 equal to integer.class. Class cl3 equal to double array.class. To create an instance of a class on the fly, use the new instance method. For example, e.getClass of .new instance of. A primer on catching exceptions. A program can throw an exception when an error occurs at runtime. Throwing an exception is more flexible than terminating the program because you can provide a handler that catches the exception and deals with it. There are two types of exceptions, unchecked exceptions and checked exceptions. Checked exceptions. The compiler checks that you provide a handler. Many common exceptions come under this, such as accessing a null reference or unchecked. The below given example, the exception occurs when an integer is divided by 0. So we can use arithmetic exception to handle the error and print the exception object. Example. Using reflection to analyze the capabilities of classes. The three classes, field, method and constructor, in the java.lang reflect package describe the fields, methods and constructors of a class respectively. All three classes have a method called getName that returns the name of the item. All three classes also have a method called getModifiers that returns an integer with various bits turned on and off that describes the modifiers used, such as public and static. Methods like isPublic, isPrivate or isFinal in the modifier class to tell whether a method or constructor was public, private or final. The getFields, getMethods and getConstructors methods of the class return arrays of the public fields, methods and constructors the class supports. The getDeclared fields, getDeclared methods and getDeclared constructor methods of the class return arrays consisting of all fields, methods and constructors that are declared in the class. Using reflection to analyze objects at runtime. You can use reflection to look at fields of objects that were not known at compile time. If f is a field, then f dot get of obj returns an object whose value is the current value of the field of object. The call f dot set of object comma value sets the field represented by f of the object obj to the new value. Using reflection to write generic array code. The array class in the java.lang.reflect package allows you to create arrays dynamically. An array of objects cannot be cast to an array of some class. To be able to make a new array of the same type as the original array, we need the methods of the array class in the java.lang.reflect package. The static new instance of method of the array class that constructs a new array is a key. You must supply the type for the entries and the desired length as parameters to this method. Object new array equal to array dot new instance of component type comma new length. Design hints for inheritance. The following are some hints for inheritance. Place common operations and fields in the superclass. Don't use protected fields. Use inheritance to model the is-a relationship. Don't use inheritance unless all inheritance method makes sense. Don't change the expected behavior when you override a method. Use polymorphism, not type information. Don't overuse